So here we're creating a spatial anchors. And then by kind of scanning the space and getting enough data, the anchor is created. And now we're able to, on multiple devices, by both localizing to the same anchor, we're able to share the space and, share the same view of a 3D model. So again, this is just a way to anchor digital information to the physical world. How does the system work? So we'll talk a little bit about specifically Azure Spatial Anchors and how you can use it in your work. So at release, Azure Spatial Anchors worked with AR Core and ARKit enabled devices, so iPhone or Android phones, which took the images and poses from the AR framework. Also with HoloLens 1 and 2, which takes basically in that case directly image features and poses from the head tracking. And most recently, we've introduced the Azure Spatial Anchors Linux SDK, which is a research distribution which allows you to kind of bring your own simultaneous localization and mapping framework. So you can get your poses from wherever you like. All you need to do is put in the undistorted images and the poses of the camera when those images were taken, and you're able to utilize this framework. This is all done within a session, so a session contains kind of the image features and image poses in a short span of time, and from that you can create anchors by specifying a relative pose relative to the current device position and get a unique anchor ID in return. And then other devices or yourself again can query the same anchor ID and get the relative pose in return. So you can create anchors on any of the devices and query them again on any of the devices shown here, which makes it quite a powerful system. The only restriction is you have to be connected to Azure. This is a cloud-based service and cloud-based service only. So let's take a look at how this works on the real robot. So here's we see a HoloLens localizing to a spatial anchor. This is the onboard HoloLens view. You saw the coordinate system just pop in. Spot is able to localize to the same anchor by using the image data from one of its front-facing cameras. Once both the HoloLens and the Spot have found the same anchor, they know each other's pose and their pose relative to one another. This allows great human-robot interaction scenarios. For example, sending Spot to a goal from the HoloLens point of view and the come here gesture we showed at the beginning of this presentation.